All right, folks. So the directions tell us to find the domain and range using both interval notation and inequality notation. All right, so we got a fair amount of writing to do, but it's not crazy. So domain again is just indicating the x values for which the function exists. So basically, if I'm talking in terms of the interval notation, I just want to identify the starting point and the stopping point in terms of x. All right, so in terms of x, where does this graph start? -5. Where does it stop? 7. All right, so what's my fencing? So is it going to be brackets, parentheses, mixture, parentheses all around?
Yeah.
And why is that?
Because the circles aren't filled.
The circles aren't filled, exactly. All right, so open circles correspond with parentheses, closed circles correspond with brackets. All right, so now we just have to make a statement of what this would relate to in terms of the inequality notation, also known as set notation. So I could say -5 is less than x, which in turn is less than 7. All right, so we're just saying that all the points, x represents the points, so all the points are between -5 and 7, non-inclusive of either of them. All right, so now for the range. What's my lowest value of y? -6. Is that included or not?
Yes.
Yes. So -6 with a bracket. And what's my highest value of y? 8. And that is not included, so parentheses. So, or, what would I write for inequality?
-6.
-6 is less than or equal to y. And then 8 is greater than y.
And 8 is greater than y, so I could just do a quick less than y. All right. So every one of these questions is going to be some variation on that same concept. So sometimes you have to count it yourself because in the next one it's not labeled for you, but you could just go through and do that yourself. We're 1, 2, 3, 4, 5 units to the left. 1, 2, 3 units to the right. 4 units down. 5 units up. So with that information, you can kind of blast through it because all you're doing is identifying the start point and the stop point for both x and y. Right? So the easier way to do it is in terms of interval notation because it's just less writing. Right? So the domain would be what?
It'd be -5 to 3.
-5 to 3. Now, are those points included? Yeah. So there aren't any clear closed circles at those points. So you might say, well, how do I know? Well, there isn't an open circle at either of those points. Right? If there isn't a clear open circle, you assume closed circle. All right. So, or I'm just going to write the same thing just with the interval inequality notation. So the range. What's my range?
-4 to 5.
-4 to 5. The same deal, brackets. And really, you know, when you get the hang of this, the only thing you have to worry about is accidentally writing an x when you should be writing a y. All right? That's the only thing that people tend to mess up when it comes to this stuff. Like they're asking for the range, it's no longer x, it's in terms of y. All right. All right, so what's my next one?
Oh, your next one. Well, domain would be -5.
-5 to 4. And my range?
Oh, -1 to 5.
Negative 1 to 5. And the last one is the fun one, because we have arrows. We like arrows. Arrows greatly simplify things. This is the one exception to what I was saying before, where interval notation tends to be the easier way to write things, because in this case, inequality notation, or set notation is really what it's called. We just use them interchangeably. It's just, set notation doesn't always tell, students like inequality notation as a name because it tells you what you're supposed to write down as an answer, right? But sometimes your answer will not be an inequality, so it can be confusing, right? In set notation, which most often involves inequalities, all I would write, so I'll write the or part first, is all real numbers. All right. Now, technically, the proper notation is squiggly bracket, and it's really squiggly brackets for all of these, x such that x belongs to the set. So that funky E means belongs to the set of all real numbers. I mean, it's a little overkill, all right? Everybody know, like, I'm just thinking in terms of the regions. I've mentioned this before, that depending on how the question's asked, you may have to write your answer in one form or another. They're never going to require you to write your solution in this form, right? But it would be really nice if you made an attempt to write it in this form, because moving forward in higher level math classes, if you can master this form of writing a solution, you'll be I was going to say thankful for it, but I don't know if that's the right word. It'll be easier on you, right? Because then you're not going to be trying to decode different notations as you go. You'll have it mastered already, right? The interval notation here is negative infinity to infinity. All right, and I know that that's true for both the domain and the range, because, and this is really more of a kind of a thinking part of the question. It's like, where does it start, where does it stop? All right, so if I follow this path forever in this direction, where would it go? Well, if I'm thinking in terms of x, it would go forever to the left. Forever is infinity, all right? Left is negative, all right? So negative infinity. If I followed it in this direction, it would go forever to the right. Forever is infinity, to the right is positive. If I'm thinking in terms of y's, it would go forever down. Forever is infinity, down is negative. If I followed it this way, it would go forever up. Forever is infinity, up is positive. All right, so when you think about it that way, it should make perfect sense. But what people were doing, and that's why I chose to go over this particular page today, rather than just give you the answers, is people were saying arrows means infinity. Yes and no. I mean, it's a good working definition, but what was happening is when people were matching up their graphs, what they were doing was taking any graph that had an infinity in it and looking for a negative infinity to infinity to fit that. Right? Well, if you have a graph that's going just to the left, the arrow is pointing to the left only, then it's only going to negative infinity for x. It's not going to positive infinity. So why would I be looking for negative infinity to infinity, right? So, I sensed that in a lot of cases there was a fundamental misunderstanding related to domain and range. And I wanted to make sure that we talked about it. Very, very important, folks. It's kind of annoying, but and this seems like a throwaway topic that we're, like, what could we possibly ever use this for? Why would we ever need to know this? It's going to come back over and over and over again. All right, domain and range is a concept that you're never going to get away from. All right, so we really need to master it as soon as possible. All right, does that make sense? Hopefully. All right. If not, then we'll talk about it more because that's how important it is. All right. Also, we're going to take a group test on this because, like when we worked on the activities on Friday, when people were doing it the right way, and I remember complimenting you all because you were doing it the right way. Period 9 was a different story. Had a little blip in that class. Somebody tried pulling a fast one, a little cheating happening, but that's going to be taken care of. Yeah, no, you all did it the right way, which is what I was looking for. I saw heard great conversations, people talking it out, like arguing with each other in the right way. Like, no, that doesn't make sense. You can't put that there. Why can't you put that there? Well, because of this. Oh, that makes sense. That kind of stuff. That's the kind of conversations I was looking for, and that was good stuff. So we're going to do a group test on Friday, and as long as you approach that group test the same way you approach that activity, I don't see any reason why any of you will get less than a 100 on that. All right, so a great way to start off or get really going in the second marking period. All right, so something to look forward to, not something to dread. All right, what to do is actually jump to page 10. And tackle this story graph. All right. Because what we want to be able to do is start to contextualize different situations. All right. I had a do now problem with a free write. We'll do that on a different day. It's actually a pretty cool exercise, but I just kind of want to, because I missed a day last week, I want to get us kind of back on track. All right. So what we would want to do here is create a situation that would describe the given graph. All right, so it's talking about the passage of time and the distance from home. All right, so let's just think about it for a second. What was going on here? What happened to this individual that was, this graph was based off of, a scenario related to an individual. What happened with this individual? All right, so what do you think? No, not even an equation, just an explanation.
Like, so, person went somewhere and then went back home.
Person went somewhere. Then went back home. Now, there is something related to the graph that kind of elaborates on this a little bit. So we want to think about that. Let's think in terms of slopes. All right.
So I'm creating names as well.
Okay.
So Poe ran to the park and met up with Joaquin, and they took a walk through the park, and then Poe ran back home.
Ran to the park. Met up with Joaquin and walked through the park. Then Poe ran home. All right, so what this second explanation, so both of them are correct, all right? If it's a multiple choice question, you'll have the different scenarios given, and I think it would be pretty easy. It's when you have to write it on your own and you have to incorporate the appropriate amount of detail that things can get tricky. So you have Poe went somewhere, then went back home. True, absolutely true. Poe ran to the park, met up with Joaquim, and walked through the park. Then Poe ran home. Also true. Both are factually accurate. All right. So think of a multiple choice question where it says which of the following are not true based off of the graph. All right. So choice A, this one. Choice B, this one. Give me another scenario. Somebody. Because I have a tendency to kind of steal this example and make it a multiple choice question and then put it on a test or a quiz or an exit ticket.
Someone drove to, let's say like a mall and walked around a bit and then drove back home.
Tyler drove to the mall. I made you a little older so you could drive. Walked around. A bit. Then drove home. I mean, grammar-wise, I just totally butchered that, but that's really just an opportunity for typo bonus at some point. So we have 3 correct scenarios, all right? In every case, we took into account that a person's distance from home was changing, all right? They started off at home, distance was 0, and then later on, their distance was also 0, all right? The slope represents what?
The speed.
The speed, all right? So the speed was increasing away from home. Then we slowed down, the individual slowed down, and then sped up in the direction of home, all right? The steepness of the graph is what indicates the slope. That slope tells us about the velocity or the speed, all right? So we know that there is a slowdown at some point, all right? So these 2 examples, the Poe and the Tyler example, both indicate that the individual was moving at a faster rate, then slowed down, and then was moving at a faster rate again, all right? So as long as your example covers that concept, then you have a correct example, all right, or a correct interpretation. So all I would have to do to come up with my 4th choice is come up with something completely incorrect or even absurd, all right? So think of a multiple choice question. Which of the following is not true? I could say Joe started off at home, walked casually to the park, took off in a full sprint, and then walked casually home, right? So the exact opposite of what these other ones are saying. And in fact, in that example, it would be pretty easy to say, all right, well, that's not right because it's the exact opposite of these 2. And if we're looking for the one that doesn't fit, you wouldn't even really have to look at the graph. Right? But the challenge here is to be able to interpret different types of graphs that aren't just related to time and distance. All right, so that's one of the focuses of this course is to be able to take the mathematical concepts that we learn throughout the course and apply context to them. All right, not the easiest thing in the world, but it gets easier with practice. And